Hello, and welcome to the DCL Learning Series. Today's webinar, our first of 2025, is titled Genius Without the Gibberish, How RAG and Structured Content Boost Generative AI Reliability. My name is Marianne Callahana, and I'm the VP at Data Conversion Laboratory. Before we begin, I want to let you know this session is being recorded and will be available in the on-demand section of our website at dataconversionlaboratory.com. We will absolutely save time at the end of this conversation to answer any questions you have, but please feel free to submit your questions, your comments, your thoughts via that questions dialog box in the platform. So before we begin, I do want to briefly introduce my company, Data Conversion Laboratory, or DCL, as we are also known. We are the industry-leading XML conversion provider. We offer services that involve structuring content and data that support our customers' content management and distribution endeavors. Increasingly, we help prepare businesses to be AI ready. DCL's core mission is transforming content and data into the formats our customers need to be competitive in business. And we believe that well-structured content is fundamental to fostering innovation and foundational for your own AI readiness. So today's speakers, I'm thrilled to introduce DCL's Power Trio. We have Mark Gross, President of Data Conversion Laboratory, Tammy Belitsky, CIO, and Rich Dominelli, Senior Solutions Architect here at DCL. Honestly, you can throw any complex data content challenge at them and they will deliver a solution. So it's an honor to work with these three, and I'm so thrilled to have them here today to discuss RAG with you. Mark, I'm going to turn it over to you.
Oh, turn on my camera. There you go. Okay. Okay, this is an interesting quote from Gartner. I mean, it says by 2025, and the date on it is October 2024. So they're already prognosticating that 100% generative AI, virtual customer assistants, and virtual agents that lack integration to modern knowledge management systems will fail to meet their customer experience. And that's probably true. I mean, if you look at the chatbots you go through and the automated things you're working with, unless they're very, very sophisticated and really have a lot of information at hand, that they're not a very pleasant experience. And I think what's happening is, I mean, we've been doing data for a long time. We've been working with all kinds of data systems for over 40 years. And every few years is a new challenge that comes along and a new opportunity. And the opportunity of the last couple of years has been generative AI and AI in general. And how do you use these systems to make them work for you? And the issue is that large language models, the source of generative AI, has not proved to be good enough. Although when we talked about it 2 years ago, and every conference I went to, this is like going to change the world totally. People have been disappointed, and part of it is that it's not. While the answers look very good, they're not necessarily complete or truthful, or there's hallucinations, all those kind of things. And the problem is that those models just don't have first of all, don't have current information, because it takes a long time to create a model, so it might be 2 or 3 or 4 years old by the time you get to it, and it won't have your specific information. So while making your own up-to-date and making up your own LLM for your own company is a theoretical possibility. It's only a practical possibility. It's an expensive process, a lengthy process, and very few companies are in a position to really spend that kind of money. So what we're talking about today is splitting up the roles between what LLMs do and generate text very, very well, and really the other part of how do you get up-to-date information, which is RAG. Go to the next slide, please. I think there it is. So the question is, why is RAG important in a business setting? Because it really supplements where LLMs alone fail. LLMs are very good at generating text and images when they have the complete information. Uh, but 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 if they don't, funny things happen. Like, for example, this image over here was generated totally by I think it was ChatGPT, and it came from a quote. I mean, I could read part of it, but can you create an image for my presentation? I need something that visually represents the key LLMs. What LLMs are great for doing things, but they need and give me a creative way of saying the following phrase. Give me an image that does this or that, but it's even better for summarizing information and so on. So it went and created this from that sentence and its base of information it had already. But if it doesn't have all the information, uh, uh, think about it. LMs are good at doing something like this, and it's summary information, but they need more information than they currently have. So let's go to the next slide. So, key applications today of LLMs, chatbots, sometimes helpful. Google results, mostly valid, sometimes valid, you don't always know. Internal LLMs are very costly, like you said. So LLMs themselves are very good at generating human-like text, but they make mistakes. And if you look at both these logos are actually generated by ChatGPT, and ChatGPT has its own. That typo is not us. That was generated by ChatGPT when it produced this logo. And the same kind of thing in Llama 3 below. It got the llama part in the picture, but it got the text a little bit off. The limitations are that it doesn't have all the information. Let's go to the next slide. This is just a test we did with a simple question asked on ChatGPT. We told it use only the information available here, so we specified it. Told it where the PDF is to go look at it, and print me a list of officers, their positions, their ages that appear in a section titled Executive Officers of the Registrar. So that's that's a pretty clear discussion of it, a pretty clear question. So let's take a look at the results that we have here. So, and by the way, that PDF that I told it to go to, that's this. And this is the page we told it to go to. And this is a section we told it to go to. Again, very clear. But what happened? So here's the results. First of all, rather than grabbing and reparsing the PDF file that it had, it decided also that it needed to go out to its own initial database someplace out there. And the information it came back with looks pretty good, but there's a few things to note here about, when you look at it, when you compare side by side. For example, Michelle Browdy's age, it gave her an extra 3 years in age, which she probably doesn't appreciate. And where did she get that? The title is different because it grabbed it from someplace else. It missed a few people for whatever reason. It did get James Kavanaugh, which is the SVP down there, expanded his name. Also gave him about 4 years extra. By the way, the green is the chairman. It did get completely right, so that's impressive. And then it added a few people there. The people that it added, Fletcher Previn is a CIO indeed, but he's a CEO at Cisco, not IBM. Kenneth Barian is a chief strategy officer at IBM, who's not even in the listing, and so on. So whatever reason, things happen. There's hallucinations that happen, and uh, and uh, and so what Durag will do, and I'll turn this over to Tammy in a second. What Durag does is, in big picture, is it's taking information that you know is truthful and feeding it into the chat GPT so that you limit all the places that it could get wrong information from. And to get a little more detail on that, let me turn it over to Tammy.
Okay, thank you. So enter RAG. RAG stands for Retrieval-augmented generation, and it's a term that, unlike many other technical terms, actually describes the capabilities that it offers. Mark mentioned how AI may be error-prone and hallucinate, delivering results that may or may not be correct. And this is largely not because of the LLM model itself, rather the data the LLM is using to respond to your query. To explain this more clearly, a standard LLM will pull data from any source it can access, whether it's structured, unstructured, verified, or just information that's out there on the internet. And this clarifies the value of RAG and exactly what it brings to the table. RAG allows you to pass your data, ideally structured, curated, and verified, with your prompt. And it harnesses the power of the LLM by telling it to respond to the query only using the data that's being passed to it. So in essence, RAG is enhancing AI's ability to provide accurate, relevant, and consistent responses by augmenting it with external knowledge, the data that you pass it, to leverage its generative capabilities, instead of relying just on the data that was used to train the model and what the model will pull directly from other sources. So the primary advantage that RAG offers is the ability for you to integrate your content into an existing LLM in a manageable way, reduce hallucinations, and deliver answers based on your trusted and verified sources. So now I'm going to pass it over to Rich to go through the RAG architecture. Rich?
Hello, everyone. So as this slide demonstrates in a simplified format, there's really two aspects to the RAG architecture. The first is the data preparation side. And this is very similar to what a lot of people do when you're building knowledge bases, where you're going through a list of data sources, you're extracting information, and the information can be present in unstructured, it could be present in external websites, it could be in your own databases, it could be set of PDFs. So we want to go through the steps necessary to take that information, make it easily retrievable. So doing that is basically going through a structuring and chunking phase, which is something we do pretty regularly around DCL, where we're taking the information, we're extracting front matter and back matter, we're extracting keywords, we're extracting as much metadata as we can out of the document, as well as subject matters, all to eventually end up in this vector database, this hybrid vector database to act as our corpus. The other thing we do now, which is kind of new to the picture, is we do a embedding step. And what we're doing for the embedding step is we're taking the body of the article and we're running it through a text embedding step, which is identifying semantically what the article is about. And that will allow us to do the pieces of, we want to take the user's query and we want to match it based on the subject matter against the body of the article. So all of that occurs before LLMs or before the user's prompt ever enters the picture. That's the prep step. This is stuff that people are doing already for their existing knowledge base, but this is taking it one step further. So now we enter the RAG pipeline. So the user who is trying to use either a chatbot or query your knowledge base in some way, they're going to type in a prompt. The form of that prompt can, or how he does that, can vary based on your system. But we're going to take that prompt that the person entered. We're going to also run it through a text embedding step. And what that does is it's going to convert the text prompt much the same way we converted the actual body of the articles into a format that we can do semantic matches, which is basically an array of numbers which identifies not only the words in the prompt, but also an essential meaning to it. In addition to that, we're going to look at the prompt and we're going to extract whatever relevant data, keyword extractions, hard data points like referenced authors and that type of information, things that we can use to really narrow down what we want to get out of our knowledge base, and take the information from our knowledge base based on what the users entered semantically in the text embedding step and those hard data points, and query our vector database. Now the results of that query are going to be appended to the person's prompt, and we're going to modify the person's prompt to essentially say, from the information I'm presenting here, answer my question. And what that does is it eliminates the reliance on any previous training. It minimizes the amount of hallucinations that the LLM is going to engage in, and it's going to give you a much cleaner answer from the information that is most pertinent to what the person's query is, and it's coming from your data as opposed to previous training or information that you're not aware of. So you can actually source the elements from your vector database and where they come from. So that being said, next slide. And back to Tammy.
Tammy, you're on mute.
Good point. Thank you. All right. Thanks, Rich. So let's dive a little more into the content preparation portion from that RAG architecture slide, which is critical to improving the accuracy of the AI result. The importance of this step should not be underestimated, as it allows you to define and create your RAG universe. It makes it possible for you to get accurate, reliable responses from the LLM. The key areas to focus on now are the first two steps on the architecture diagram. The first is the content extraction, where you can take disparate data sources in a variety of formats and quality levels, including PDF, audio, website content, and use different methods to extract the content and turn it into quality data. At DCL, we've been doing this for years, and we use many different approaches and solutions to accurately get actionable data from print, PDF, Word documents, and a growing area now is video transcription. Then, once you've extracted the content, the next step is to structure it and transform it from raw, extracted data into intelligent content. Intelligent content is essentially synonymous with structured content. And at DCL, we typically recommend XML because it's an attribute-rich format and remains one of the most effective structured content frameworks in use today. XML is optimized for authoring, producing, and distributing technical and non-technical information, making it the ideal medium for organizing and managing your valuable content. Flipping back to our diagram for a minute, on the next slide, please, thank you. Let's stay focused on the left side of the diagram, the data preparation. So data preparation, as we mentioned, is a core DCL service. And while we've been delivering data preparation services for decades, we're continually developing new and advanced solutions to extract and prepare the data, taking full advantage of and contributing to evolving technologies. And it all begins with selecting the right sources and extracting quality data from these sources. Extracting the data and structuring it, again, is DCL's area of expertise. This is where we develop and optimize tools and solutions to process large repositories of variant sources. And then we transform that data into XML and populate the XML with any required metadata that can be automatically extracted from the source content and even external sources, external databases or related systems. The last step, as mentioned, which I touched upon a little earlier, is embedding, where we prepare the data for the LLM by converting the structured or textual information into the format required by the model, numerical arrays. And now I'll hand it off to Rich to explain a little bit more about that intricate process and tell us what that means. Rich? Rich, you're on mute now.
So I am, sorry. So text embedding is actually a big jump because um, prior to Word2Vec and some of these other text embedding toolkits that have hit the market, um, we would extract as much information we can as out of the article and create front matter and back matter, but the essence of the article's meaning was still kind of lost in the body of the XML that we were capturing. Text embedding takes it a step further because now what we're doing is we're creating numerical representation of each individual sentence or each individual section within the article, and we're putting it in a format that computers can understand and query against based on content. So what this diagram is trying to represent here is how close in an answer space, theoretically, each of these individual phrases are. So canine companions say woof, the text embedded vector, which will just be an array of numbers, is going to be close to feline say meow and bovine buddies say moo. Um, but it's going to be much further distance to a quarterback throws a football. It's almost like, for those of you who are old enough to understand the Dewey Decimal System and remember that back in as a way of organizing the library, it's almost like taking each individual part of a document or each individual part of a corpus and organizing it in a detailed subject matter, so that the relationship between those become represented based on the numeric arrays that appear out of that content. So if we can go a step, next slide. What does that let you do? Well, we already have a well understood problem space of trying to find data based on keyword extraction and relevant pieces of information that are being pulled out of the articles. This is the structured data like references and authors and keywords and dates and institution and funding sources that has been the bread and butter of conversion companies, DCL being at the top of that for years. And the use for that is very clear as far as being able to locate content very quickly in a large corpus. I mean, not talking about a couple of documents here and there, we're talking about hundreds of thousands or millions of documents that you're combing through. Embedding kind of takes it one step further because now what we're doing is we're also being able to look at the unstructured bits of the information, the bodies of those articles, and also query directly against that in a meaningful way. Next slide, please. So if you're like me and you're reading and trying to find out what RAG is about, behind the scenes, what's really going on is as simple as what you're seeing on the screen right now. We're going out, we're doing a query against an external data source. In our example, it's a hybrid data source. It could be a graph database. It could be a lot of different sources of information. And we're taking the results of that query and we're appending it to the prompt. So looping back around to our 10K discussion example from earlier, instead of saying, here's a PDF, here's the section we care about in the PDF, go find it yourself, Mr. LLM, and come back with relevant data. No, what we're doing is we are performing a query, obtaining the information out of our corpus and appending it to the prompt that the user created. So we're rewriting the prompt to include the results of the query. In this particular case, we're rewriting the prompt to include the relevant section from the PDF and saying, please go out and get the information using only this data. So this is the updated prompt. And at first glance, when you see an example like this, it almost looks like you're cheating. And this is a very simplified example, but the same works true if you have a huge collection of data out there or an entire database full of 10K information and you want to extract only the information you care about. But given that simplified example, we can go to the next slide and see what the LLM produced when given this prompt. So now you'll notice that it has a perfect score. So when presented with only the data we care about, which is really the secret to LLMs, it was able to actually summarize that data and give us the correct results, minus the hallucination and people who work for other companies, and minus any information that it's trying to come out of its training with, and give us absolutely accurate results based on the data that we gave it. Next slide, please. And now back to Tammy.
Okay, thank you. Um, so now we've covered what reg is and what reg isn't. The key message that's become very clear is that the data that you pass along with your prompt, your verified, curated, structured data, is fundamental to receiving accurate responses from the LLM. Building on that, you want to make sure that you're passing all the data that is needed to get the best response. The challenge now is that today, with the current technology, there are size limitations as far as how much data you can pass to the LLM with your prompt or your query. So you retrieve the data from the repositories, you merge the data with the prompt, and if there are no limitations, you could append the entire data set to your prompt to generate the results. But context size, which is the amount of data you can pass to the LLM, is limited today. And as you can see from this slide, each LLM has different restrictions. And understanding now that the data you pass to the LLM is the key to RAG, it's not surprising that LLMs are increasing their context size. And I do expect that this will continue to be a competitive area of growth for LLMs for the next long time. But the reality is that LLMs do have limitations on the context size, which controls how much data you can pass to the LLM with your query, which offers another advantage to structured data. For example, when data is structured, we'll typically extract the graphics, which are often large, and we'll save those as reference files. So the structured data that we pass to the LLM may be smaller, allowing you to pass more of the relevant content and get more accurate responses. And now I'll hand it back to Mark.
Okay, so yeah, I love the way Rich introduced that. It's just almost like cheating. You're giving it all the answers, but it's not. It's a very simple explanation. I mean, you could have just as easily have given it that entire an entire annual report as a source, which would be 25 or 30 or 40 pages, and it still probably would have come back with similar results because it's now not looking at external sources, and 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 RAG, as we're talking about, it really gives you the ability. The question has always been, what do I do with the stuff that's behind my firewall? What do I do with my private data? What do I do with all those things that are really my competitive edge? And the answer is that that becomes very valuable. If, your data repository is still valuable. It's probably even more valuable than it ever was before because people can now get to it and be able to get information from things that only you have in your repository that others don't. So I think there's a lot to be said over here, and I think it's all very exciting in a new frontier of how to use information. Rich, Tammy, what do you think? Is structured content the future of AI? Is this where we're going?
I guess I can start that off. I strongly believe that the answer to this right now is yes. There may be, and there will be different techniques applied over time to mine data, vet out irrelevant data, and even to verify data. And following the patterns of technology as we've seen them evolving over time, RAG will continue to evolve, and it's likely going to be replaced or transformed by newer methodologies, newer technologies. But regardless, at the core, data, quality data, remains your key to AI. And being able to pass your structured, verified data to the LLM is likely to continue for the foreseeable future to deliver faster, more consistent, and more accurate results. Rich, what are your thoughts?
So I absolutely think it is, but I think my reasoning for it is, coming into the LLM space, looking at what was out there, I expected, and I think a lot of people have this expectation of being able to ask it anything, and it's going to go out and find the answers and the information for about what I'm asking it. So, I like to use this example of the 10Ks because it's one of those problems that we have tried to tackle a number of years ago, and it had its challenges because of formatting and other things like that. And I was routinely disappointed. And I have tried this problem against multiple LLMs, ChatGPT, Claude, um, Llama, and I always found that if the if the LLM doesn't know what it's talking about, if it should just come back with an answer that says, sorry, I'm not able to figure that out, or I don't have access to that information, frequently what happens is it will just make something up. And that's the hallucination conversation that people are always having, and why hallucinations are mitigating the use of LLMs and causing a lot of disappointment in the business community with LLMs. What RAG does is it allows you to go out and constrain what the LLM is doing, and have more refined control over what it's doing. And that lets you turn around and get much more accurate and good results and improve, as that Gartner quote said at the beginning of the webinar, improve the customer experience and hit that customer experience goal. Well, then it becomes an exercise in a fairly well understood problem. We have a large corpus of data. It's our data, or it's our knowledge base, it's our articles that we're feeding to an index or whatever. It becomes a well understood problem of how do I accurately query that information, and then the LLM becomes like a summarization tool. It becomes a tool for, okay, this is roughly the content that I think you should be looking at. Summarize it and present it in the way that I'm asking you to present it in. That's a much better use case for LLMs. And it almost becomes part of your presentation layer where it's going out and it's getting the information through traditional means. We've added semantics to it, which is a big jump. But then the summarization piece is really where the LLM shines. And the structured data component, being able to have those metadata bits, are a huge piece of finding that data that you want to query and feed to the LLM, and do it in a quick and responsive manner. It goes without saying. You need that structured data out there to be able to query your content now more than ever.
Yeah. Well, and actually, Ush, I love your Dewey Decimal System metaphor. That's still out there. I still go to the library occasionally, and that's still the way you find books. But what it's sort of taking it, just like other things, you've taken it. Computers have allowed you to take it to the next level, because when just looking for a book on that number forgets that some parts of the book belong in other places. Here, you just the embedding part of it lets you tag basically every paragraph or every sentence or every
Yeah.
phrase is really identified by where it belongs, which is so. Uh, so the Dewey Decimal System, when it was introduced 150 years ago, was a tremendous next step in how you find information. This sort of takes it to a level that only could be done with the high-speed computers we have today. Um, Let's just you mentioned the use cases, and really going back to the phrase before about what are the use cases and how do you integrate them into. Let's just go through a few of them. A customer support system. it's not just answering questions about where's my order. It's also answering questions about supporting all the technical information they've got. Customers have very sophisticated queries. A telephone company, a telecom company that's trying to support all kinds of technical material, they can have that database that they've built with all their different products. It could be thousands of products and hundreds of thousands of pages, millions of pages, or whatever pages are today. And the RAG part of it lets them find that particular piece of information that a customer support person will need. And then the LLM part of it, the chat part of it, will be able to put it together in a way that's understandable to a customer. And by doing this, you don't necessarily always need a customer support representative doing that. That chat function on your computer can become much more powerful. Same in healthcare and finance and other professional areas where you have lots of very specialized information that's not on the web or shouldn't be on the web, and this lets you and so you can get access to those very large collections of medical publications and journals and in the law area, law any place in the world, and be able to answer questions. And by RAG finding the relevant parts of it, instead of having to look through a million pages, which LLMs can't really do very well, or can't do, it'll identify the 50 or 100 pages you need to look at and be able to identify that. The e-commerce, I mean, working more and more people. I don't know if most people are using online ordering these days, but I know I do a lot, and a lot of times I'm asking some questions on comparison of information. How do you get that information together? It's not there today. I still have to go to a bunch of websites to find things, but an agent that can go out and find that information, find the relevant information, and answer and put the information in a format that you can use, put it into a table, put it into a picture, put it in something would be a very valuable way to do it. So. And the same for all these other places. And you can see crisis management, one of those places where you really, talk about the fires on the West Coast now, but any crisis management area where you suddenly need to have lots and lots of information that you've been collecting and not easily available, but if it's all digitized, if it's got the right information attached to it, if it's got the right structuring attached to it, it can be instantly findable by a computer so that the end user can get to it or a specialist in the middle can get to it. And those places with seconds count, this can be a game changer in how people process information. We could go on lots and lots of case studies like this all over. Some of them I think on our website, and I think that's I think that's as far as I don't know, Marian, do we have any questions, or do you want to go any place from here?
We do have some questions.
Okay.
So I'm going to, I do just want to share this screen with our attendees. We've been collecting RAG resources. Rich helps keep us all informed internally, and we do share them on our on a blog on our website. You can scan this QR code, or our colleague Leanne is also going to push out that URL, so you can go there directly. Rich, one question for you. When will AI auto mute and unmute participants in a meeting? But seriously,
Actually, we could do that. Look at the person's mouth and then automatically, yeah, that would be good.
yeah.
Yeah.
But
They can
so
probably
one
do that
question.
today because there are
Yeah.
like muffled devices that cut out outside noise, which will let in a person's voice directly. So they're figuring it out somehow.
Right, yeah.
Teams will do that today. When I start talking, sometimes it will say you're muted. It is detecting it. I think it's
That's
there.
true. That's true. Yeah, different applications. Okay, so with the current context size limitations, how can my large corpus be effective in a RAG environment?
So I think the concept that we're discussing about is bringing the value of the structured data into that. So if you have a large corpus, number one, there are LLMs that are allowing larger and larger corpuses and large context sizes. And then again, it's taking a look at your data. That's part of the data preparation. What is your data? Why is it so large? Is there data that we can remove that is extraneous? It's not relevant. No, it's not. That makes it not AI RAG ready. What is in your data that doesn't have to be there? And as part of the preparation, you pull that out, pull out the graphics, pull out anything that's not relevant, so that the size of what you're passing to it with your prompt becomes manageable, comes within the guidelines, but still helps you drive the right answer. That would be my first response. Rich, you want to add to that
Sure.
one?
So, one of the strategies for accommodating something like that is when you're ingesting your data into your from your corpus into your database, you're not doing it at a document by document level. You're doing it in manageable chunks. So, in addition to having the structured information about the document as a whole, you would have a collection of chunks that are part of each of those documents. The chunking strategy will vary based on the use case. It might be section by section, it might be page by page, it might be smaller or larger than that. But then what you're doing is you're going out and you're doing a semantic and keyword query to find the most relevant chunks of information that you're going to append to your query. And if it's the correct hit, then the query will have a much better hit, a much better response. So there was a case study that is probably in our resources, and if not, I can dig it up, from Carnegie Mellon, where they were going through all of the academic papers and their internal correspondence, and they had a huge curated collection, and they decided to arbitrarily chunk at 1K chunks. So every document they had, in addition to having metadata and that sort of thing, they broke into 1,000 byte pieces. And then when they went and did their query, they did it based on the metadata. And they did a semantic search, and then they used the metadata to further refine the list of information that was appended to the query, and then do a much more constrained query after that. And that's one approach, and it really depends on the scenario. There isn't a perfect, cookie cutter answer across the board. Finding your data is the most important part, but chunking your data is a big piece of it. And that comes back to the structured content discussion.
All right, thank you. And if we do not answer your question, please know that we will be in touch after this webinar. That goes out to our attendees. Okay, another question. Does your raw data source have to be consistent? For example, we get technical documents from automotive engineers, and they are in Excel spreadsheets, but not every spreadsheet is set up the same way for all vehicles.
Well,
So
again, that's what. Sorry.
yeah,
You
it's
can go ahead.
content homogenation.
Yeah,
Go ahead. I mean, we tackle that sort of thing all the time. That's not
yeah, yeah.
that's not
That That's
just
TCL's
no,
bread and butter, is taking repositories with content in all different formats, totally inconsistent. It's so rare. When we do a project, we'll get a sample from the client, and you do your first customizations and setup based on that. And when you start getting production data, it often doesn't look anything like the samples because content is just so variant. So that's why the techniques and tools that we've developed are specifically designed to be able to handle the fact that content is not consistent, because I would think inconsistent content is far more common than consistent content. And the
Normalize,
beauty is that preparation stage.
right?
And
Um,
it goes further than just Excel spreadsheets. I mean,
Of course.
today content is coming in so many different forms. I mean, so much information is in YouTubes and all kinds of other places. And the technology now to extract text out of those is just, a lot of it is just in the very early stages now. But all this information that people have been collecting over the next year or 2 or 3 will become very valuable resources. So these are these corporate databases, these private, these journals, these are very, very important assets and very valuable assets, and will continue to be important as long as they maintain properly.
One thing I want to just add to that, um, I would always approach, you should always approach these projects as if, there's going to be a decent percentage of stuff that's going to be outlier. And it's important that you design whatever your ingestion tool chain is, whatever the steps you're taking to pull that content in, with a QA step, or something that's going to raise a red flag when these things come up. I mean, even some of the projects we do with government resources, we're supposed to have a very specific form document, and then maybe one out of every 40 of them is a handwritten scribbled note that looks like it came off the back of a cocktail napkin that we're supposed to deal with.
Right.
And it's important to catch those kind of things, and be able to raise the red flag in your tool chain, and assume that even if it looks like it's 100% consistent or 99% consistent, there's going to be 10 or 15 out of every 100 that are just a little wonky or a little off.
Right. Okay, Rich, question about the classic test we always do with the 10K reports. When you provided the PDF, didn't you tell the LLM to only use the PDF? That was a specific piece of curated information. Was the temperature turned down to 0? How is that different than providing a source where that PDF was contained?
So an interesting thing in my journey of playing with LLMs is, a lot of them supported temperature and controls to keep it to the best results possible. Until very relatively recently, ChatGPT did not have the ability to go out and hit external URLs. It wasn't always consistent about telling you this, though. Sometimes it acted like it went out and did it, as in this case, even though behind the scenes it was relying on training data that it had already to pull that information. Regardless of that, the idea of being able to explicitly find that information for it and give it to it to summarize. In this case, it was a single 10K, and it's not a hard thing to pick out that information yourself. When you're talking about thousands or tens of thousands of documents in a variety of formats, then it becomes a much more interesting problem to solve. Because then the formatting is different between all of them, getting back to our consistency discussion. And even with the temperature turned all the way down, and with the best results turned all the way up, you're still going to experience a large number of hallucinations that are not always clearly identifiable. Um, we had a project where we were taking authors and affiliations as a good example. And we ran through, several hundred documents, and we're getting great results. And then we try to start using it in production, and discover that, oh, well, there's a percentage of these that are coming through that look great, but aren't. And that's really what RAG is trying to solve is, we're trying to give as much of a lift and helping hand to the LLM when we're telling it to pull information out that we can, to try to mitigate those problems and try to mitigate those errors that come out of that are sometimes very hard to discover.
In my simplified view, really, we're splitting the responsibility between the LLM, which is very good at summarizing, putting information together, from the part about finding the information in the first place. And the RAG part it becomes responsible for finding the information, which it's much better at. And that's the way I think of it. Given
Yep.
information, and summarize the 100 pages. Don't summarize the million pages out there, because you can't possibly do that. Even your Mr. LLM, you can't possibly do that.
Yeah, and I have to
Gotcha.
say, I was a little disappointed that it couldn't do that either. I was looking forward to this, bright new future of our AI overlords being able
Yeah.
to answer any questions I had, because I have a lot of questions all the time. And I'm routinely disappointed in the quality of the answers.
Okay. Do you think that RAG would benefit upfitting existing content for accessibility?
That's a funny question.
Yeah,
Before,
since we've been going through this, yeah.
We have been literally looking at that as a
Uh-huh.
specific problem right now, using LLMs for generating
yeah,
things like text and identifying foreign words in text passages. So short answer is yes.
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 And
Um,
dramatically so. I think we're all blown away and impressed by how good a job it's doing.
right.
Okay.
Um, Here's another question. What safeguards should be considered with RAG approaches involving proprietary data um, to deter misuse, content theft, or misrepresentation?
Oh, wait. Can you repeat the question?
It's a good
Yes.
question.
What safeguards should be considered with RAG approaches involving proprietary data to deter misuse, content theft, or misrepresentation?
And we're talking about using LLMs that are external, not an LLM that you're running in-house and is only using your data. Because
Right.
that's one of the first safeguards that we talk about is not using, because typically, unless you have a contract, when you're doing the APIs, when you're passing the data, they're allowed to use the data for training. So what other companies do, as ETL has done, is we create LLMs we're running in-house. The data is not going outside, and we have complete control over the data. So it's not leaving our firewall. So it's as controlled as it's subject to all the stringency and controls that we have for all our in-house data. And
Right.
Rich looks like he wants to say something more about that.
Well, I
I
think
see
it's
that
saying
look
that,
in
but
your eye.
you're really splitting up
Yeah,
the data itself is the same safeguards you always use with your proprietary
correct.
data. Your database is your database, and all the firewalls and all that stuff is there to protect it. It's really that front end that's only, and that's the part that really needs to be uh, 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 has to be software that is disconnected. That's disconnected from the internet, right? I mean, I'll leave it to you,
So,
Rich. You can get better words for that.
so the short answer is if you're feeding your prompt to a hosted LLM, whatever you're including in that prompt typically becomes part of the training material for the prompt. So how to deal with that. You can use a locally hosted, a non-prem LLM. That was the Samsung lesson that came out a few years back, where Samsung discovered that all of the information that they were sharing with, I believe it was ChatGPT, it might have been a different LLM, was suddenly becoming part of the training data and cropping up in other people's queries. So you can do, and what they did is they brought their database, I'm sorry, their LLM in house. Llama, which is Meta's data LLM offering, runs. You can run some of the larger models locally if you have the hardware for it. The other thing that's starting to crop up, Anthropic, I think, was the first people to do it, but you also see it with Microsoft's cloud offering, is they will host it for you in an isolated instance where you can say, we're still calling a cloud resource, so you're not bringing in these monster GPUs and servers, but your information is contractually isolated to only the instance that they're holding for you, and will not be shared with other customers and will not become part of the general training set. So if you have the facility and you're happy with the results for an on-prem LLM, I would recommend doing that because there's no way it's getting out then. You can certainly put tools to make sure your LLM isn't sneakily communicating to the outside world, like Glasswire or that type of thing. Or look at some of these hosted solutions that are dedicated to you. They're not cheap, but they are
They're
out there,
pricey.
are becoming more available as things move forward, because it's a pretty common use case where people want to have LLMs, want to use an LLM, but don't want to share anything that they're doing with the outside world.
Right. And I would just add from the business side, it's really important that all organizations develop their own AI usage policy. Just as we at DCL, because we're ISO certified, at our company meetings, Tammy always makes sure that we have an education session and our staff all know how to responsibly use any LLMs that we might be interacting with. Okay, another question. Do you use the same embedding tools for both data prep and processing the user query?
Ideally, yes. Sorry, I think I echoed there. Ideally, yes, you would use the same library for both. One of the things that people aren't normally that conversant with is when you're doing the embedding step, um, it is looking at the problem, at the answer space of text embeddings that you've run before. So if possible, and you can store and continue to use the same one, you'll get better results. There are a number of them out there. There are some specialty ones out there for supporting things like medical journals and that type of thing. I would encourage playing with a few, not just picking, the first example you come across just because that happened to be whatever Stack Overflow tutorial recommended. You play with different ones because your results will vary.
All right. Question is, are you using a vector database? If so, which one?
Right now, my favorite is a hybrid vector database, which is the PG Vector add-on to Postgres 16, because that lets me have the best of both worlds. I can have relational data associated with the information that we're storing in the database, and as well as being able to do the cosine similarity type queries again to do semantic queries and do the distance type checks. So that's my personal favorite. There's a ton of them out there. I came to this solution with a Postgres predilection, and I've used it in a bunch of projects, so that might be swaying my answer slightly, but it works well, and I don't hesitate recommending it. It's a little bit of a bear to set up, but once you get it set up, it's great.
Okay. We have more questions that I know we're not going to get to, so we will respond. Myself, Rich, or our other colleague David will definitely be getting back to some of these questions. Final question: Do you know of any publishers currently using RAG in the way that you've shown today?
Well, Carnegie Mellon used it for one.
Okay. All right. Well, we are at the top of the hour. So thank you everyone for taking time out of your day to join us here at the DCL Learning Series. And our learning series comprises webinars such as this. We also have a monthly newsletter where we curate content such as this that we find very informative. We have our blog. And you can access many other webinars related to content structure, XML standards, AI, and more from the on-demand section of our website at dataconversionlaboratory.com. We do hope to see you at future webinars and hope everyone has a great rest of their day. Thanks, Rich, Mark, and Tammy. And
Thank you.
this concludes today's broadcast.